In this video, we're going to be looking at solving linear equations again, except we're going to use some shortcuts. We're going to look at some formulas and a few other things. And I'm going to redo the problems that I did in the last video using the shortcuts. Remember, we pointed out to solve an equation means to find the number or numbers that make the equation true. And what we want to do when we solve an equation is we want to isolate the variable. Could be x, could be y. In this case, I got all x. All x is on the equations. So what we did last time was we said, okay, we have x minus 8 is equal to 10. I want to find the value of x. That's what solve means. Find the value of x. What number subtract 8 gives me 10. So we said we could isolate here by adding 8 to both sides. We get x is equal to 18. So the shortcut is going to be this. We want to isolate the variable. We want all the numbers on one side and all the variables or letters on the other side. So we got 1x over here. We got a minus 8 there. So here's the shortcut. We want the minus 8 to the other side, so just take it over and just change the sign. So this becomes x is equal to 10 plus 8. And then you just have to add these 10 and 8 is 18. And then you can always check your equation by substituting back into the equation. And you have to get the same number on both sides. That tells you that your answer is correct. Now the second one, we want to solve again. X plus 3 is equal to negative 2. So we want the x by itself. So we don't want this 3 here. We want this on the other side. So the shortcut is just take it over. So this becomes x is equal to negative 2. And if you bring the 3 over, just change the sign. You can make this a minus 3. And that's the same thing as saying minus 2 subtract 3 is the same thing as saying, that's the same thing saying minus 2 plus negative 3. And then just combine them. The signs are the same, a negative and a negative. So just add the numbers. 2 and 3 is 5. And bring down the sign. The signs are the same, so you add them. When the signs are different, then you subtract and take the sign of a larger absolute value. So this is just negative 5. X equal negative 5. Now the next one, we have 2x is equal to 20. Now this one's multiplication. So in this case, what we do, we don't have anything added over here, so we just want to get rid of this. So here, just do the regular. But this is the same thing we did in the previous video. We just divided through. We want that coefficient on x to be a 1. So 2 divided by 2 is 1. Divide both sides by 2. So on the left side, we get 1x. 1x is the same thing as just x. So I just leave it as x. And then 20 divided by 2 is 10. You check 10 times 2 is 20. It checks. Over here, for number 4, x divided by 5 is equal to 10. Nothing to do on the right side. The only thing I have to do is make, see this is the same thing. X divided by 5 is the same thing as 1/5. X, that's the same thing. Equals to 10. I could divide both sides by 1/5 to get rid of this. 1/5 divided by 1/5 is 1. Or I could just say, okay, 1/5, let's multiply that by 5. Whatever you do on one side, you do it to the other side. This is 5 here. And just say, okay, you can put this over 1. 5 over 1 is the same thing as 5. So these cancel out. This just gives me 1. 1x is x. 10 times 5 is 50. And again, you can check it. In some cases, depending on the how complex the equation is, checking it might take you longer. But here it's an easy check. Put a 50 right here. 50 divided by 5 is 10. That checks. Okay, let's look at the next one. We have 2x plus 3 is equal to negative 5. So always look at the term with the x. That's the one you want to isolate. So we want to get rid of this 3. So the 2x stays intact. And the shortcut, again, just bring that over. Anytime you bring a term or a number from one side of the equals to the other, just change the sign. So this will become not doing anything to the right side. Negative 5 stays. Bring the 3 over. Make this a minus 3. You can also make it a plus negative 3. It's the same thing. Okay, leave the 2x the way it is. And then just look at this. And negative 5, subtract 3. Just look at that as negative 5 and the negative 3. The signs are the same. So 5 and 3 is 8. Bring down the sign. They all have the same sign. It's going to stay negative in this case. Now if this had been a minus 3, when you bring it over, it becomes a plus 3. Then the signs are different. You subtract 3 from the 5 and take the sign of the 5, because that's larger, and you get a negative 2. But in this case, this is what you get. Now, we want to make this 2 a 1. Opposite of multiplication is division, so just divide here by 2, but you have to do that to the other side. So these cancel out. That gives me 1x, so I'll just put x. The 1 is understood. And then here, think of this as a minus, and a positive opposite signs. So the answer is going to be negative. Rules for division. And then 8 divided by 2 is 4. And there you have it. Negative 4 times 2 is negative 8, and 3 is negative 5. But if you're taking a test, you always want to make sure and just solve it. And if they don't tell you to check it, don't spend time checking it unless you're finished with all your problems. Then you can go back and double check to see if your answers are correct. Okay, number 6. Again, we look at the term. Now, in some cases, you might have more than one term with an x, so you have to combine those also. But in this case, we just have this one here. And then we want to isolate it, so we want this over to the other side. So I get minus 5. These are the shortcuts we're using here. Minus 5x is equal to, the 18 goes over, so that's minus 2. It's a plus 18, so it goes up when it changes from one side of the equal to the other. It becomes a minus. This is minus 5x. Okay, I have a minus 2 and a minus 18. So just look at that. You're adding a negative 2 and a negative 18, even though that's a subtraction. You can think of that as negative 2 and a negative 18. So the signs are the same. You're going to add them. 2 and 18 is 20. Because they're both negative, the sign comes along negative. Now, we still want to make this a 1x. So we're going to get rid of that negative 5. In this case, opposite of division, so multiplication is division. So divide by negative 5. These cancel to 1 and negative 5 here. So I get x. A negative divided by a negative is a positive. So we don't have to put a sign. It's understood. And then 20 divided by 5 is 4. And these are all worked in the previous video, step by step. So I'll put a link to that video in the description in case you want to go back and look at some of the steps. But here we're using the shortcuts. Okay, let's go to 7 here. And see, notice this one has two terms that have an x. 3x minus 2x. When you're solving an equation, you want to get the terms. If there's more than one term with an x, you want those on one side. So what we're going to do is this one's going to come over to this side. And when minus 2, that's going to come over to this side. We want the terms on one side. It doesn't have to be the left side, but that's normally what we do. We could put the terms on the right side, but here's the way it's going to work. 3x. We want to get the x together. Okay, so there's an x. Bring that over to this side. Just change the sign. Instead of a minus 2x, it becomes a plus. Okay, the 3 stays over here, and then we bring it over the minus 7. So change the sign. Plus 7. And then you just combine. We have 3x and 2x. It's like 3 apples and 2 apples is 5 apples. In this case, 3 and 2 is 5x. 3 and 7 is 10. So all we're doing is breaking it down, simplifying it until we get the x by itself. Now we have the x, 5x. So we want to get rid of that 5. Divide by 5. That way we come up with 1x. Whatever you do to one side, do the other side. 5. This divides out. I get x. 10 divided by 5. 5 goes into 10 2 times. Now in the last video I went through and worked this step by step, and I also did the check. But here I'm just go ahead and work these out. X equal to 2. Let's clear these. Now let's look at another one kind of like this. So let's suppose we have 5x plus 3 equal to 2x minus 8 plus x. So notice we have several terms with an x. We have a 5x there, a 2x there, and an x over here. So always look on each side and see if you can combine any terms. Well, I can't add up a 5x and a 3 on the left side. But see, so I'm going to leave that the way it is for now. This will be 5x plus 3. What can I do on the right side? Well, on the right side, if I have minus 8, if I had another, say a 3 over here, I would combine those. You can combine the numbers with the numbers and the x's with the x's. So here you want to look at this as, okay, I have a 2x, and this is x by itself. But remember, it's understood that the coefficient is always a 1. So this means 2x and 1x is 3x. Minus 8 stays the way it is. I have 5x plus 3 on the other side. The other side had 3x minus 8. I want the x's on one side, the numbers on the other side. So this one's going to come over to this side. The 3 goes over to this side. So what we'll do this is I have 5x. The 3x comes over. Just bring it over, change the sign. So it's a positive 3x. Bring it over, it becomes a minus 3x. Now if that had been a minus, then you bring it over, and this would be change it to a plus 3x equals, and we have minus 8, and 3 goes over, just change the sign. Remember, that's the same thing as adding the opposite to both sides. But here we're doing the shortcuts. So bring it over, becomes a minus 3. Now you combine the terms on each side. So here I have 5x minus 3x. So just think of that as 5 minus 3. 5 minus 3 is 2. And you bring down the x. 5x's, subtract 3x's. 5 minus 3 is 2. So we get that. Then here I have a minus 8, subtract 3. That's the same thing. You can read that as negative 8 and a negative 3. Signs are the same. 8 and 3 is 11. Bring down the sign. Both are negative. If you had opposite, this had been a negative 3 and a plus 3, then you would subtract the 3 from the 8 and take the sign of the larger, the 8, to be a negative. But in this case, we just add them. 8 and 3 is 11. And then here, to make the coefficient of the x of 1, I divide here by 2. Divide here by 2. X is equal to negative 11 over 2. Now this had been like a 10, and I divide 2 into 10, I get 5. But since it doesn't go evenly, I just leave it as a fraction. Unless I give you specific instructions. But this is going to be x is equal to negative 11 over 2. Let's clear this. Now in the next section, we're going to look at how you can apply these procedures or solving equations to formulas. Here's some formulas that are going to come up. This is the distance formula. Distance is equal to rate multiplied by the time. So this is telling you that if you know the rate, and think of rate as speed. For example, a car can go, say, 50 miles per hour. And then there's a time associated with distance equals rate and time. Now, if you're given the rate or the speed of the car and the time or whatever vehicle it is, it could be a bicycle or it could be a person running, you just plug it in there. So if I tell you a car is traveling at 50 miles per hour and it travels for 2 hours, so t is equal to 2. The time is in hours. What's the distance? So here we just plug it into this formula. Distance is equal to, and I plug in the rate is 50. So R, 50 miles per hour, and the time is 2 hours. 2 hours, so 50 times 2 is equal to 100. And always keep track of the units. What are the units going to be? Distance, well, talking miles, time is going to be in hours. So if I wanted to put units on this one, 100 miles. So given the rate of speed and the time, you can find the distance. So your car is going at 50 miles per hour and you go for 2 hours. Then the distance traveled is 100. Now let's suppose you want to find the rate of speed. Well, if you're looking for the rate of speed, you use this formula. And how do you get this formula here? Well, if you know this formula here, you're just solving this equation for r. So it's just where you're using the ideas of solving an equation. If I want to solve this equation for r, I want to isolate the r, so I divide both sides by t. T here and t here. These t's would cancel, so the rate is equal to distance divided by time. So if I tell you, I'm going to use the same data here. So if I tell you that the car traveled a distance of 100 miles in 2 hours, what's the rate of speed of the car, or the speed? The rate for the rate of speed or the speed. Well, now you just plug into this formula, which we already know the answer because we did it the other way there. So it's d, or distance in miles, is 100. The time in hours is 2. 100 divided by 2 is equal to 50. So remember, this is miles and this is hours, so this is 50 miles per hour. So given this formula, distance equal to rate times the time, you can find distance if you're given r and t. You can find r if you're given d and t, or you can find the time if you're given d and r. So let's, again, use the same value so you can see where these are coming from. So suppose I tell you that rate of speed is 50 miles per hour. And that's suppose the distance traveled is 100 miles. What's the time? So now we're using this formula. Again, we found it by dividing both sides here by r. And we got time is equal to distance divided by r. So all you do is plug in there. So if I want the time given d and r, you just plug it here. Distance is equal to 100. The rate is 50 miles per hour. And just divide this out. 100 divided by 50 is equal to 2. And since it's time, this is in hours. So if I put 100 miles divided by miles per hour, the units reduce to hours, and you get this. Okay, let's cancel this. Now let's look at the next one. Here we have a rectangle, the first one here. And we have two formulas that you can use. Maybe you'll see them later on in your study. The perimeter. So this is the perimeter is the distance around. So if I take this distance, I add up all the sides. So I have to L plus L is 2L. And then W plus W is 2W. If I add up all four sides, that gives me the distance around the rectangle, which is the perimeter. That's how we get this. So let's look at, suppose that the length is 10. That could be in inches, feet. I'm just going to say units, so it's equal to 10. And let's suppose the width is equal to 5. So you're given the length and the width of the rectangle. What's the perimeter? What's the distance around? When you look at your formula, it says this and this because there's two, the opposite sides here are the same length. If this is L, this is L. So if this is 10, this is 10. This is W and this is W, so this is 5, this is 5. So the perimeter is going to be twice the length plus twice the width. This is going to be 2 times 10, that's 20. 2 times 5, that's 10. So this is equal to 30. And I'm just going to say units. That could be feet, that could be inches, whatever. This is 30 units. They're linear units, so you just add it. Now again, let's say this is, again, same rectangle. Let's say this is 10. The width is 5. What's the area? Area of a rectangle is length times the width. And this is going to be the same for a square. Except for a square, the length and the width are the same. So it's just going to be the one side squared. So if I was going to find the area for this one, that's going to be 10 times 5 is 50. And I'm just going to say, in this case, it's going to be square units. I'm just going to put U squared. Square units. Because you're multiplying. So it's just like x times x is x squared. Inches times inches is inches squared, or square inches. Feet times feet, feet squared. There you have it. Now if you're working with a trapezoid, here's your formula. Okay. So this side and this side are parallel for a trapezoid. Those are parallel. And here's your formula. So let's suppose that this is 6 units, and say the base. These are the bases. Base 1 and base 2. And then these are parallel, so that the distance between the parallel lines, sides, is called h. Let's suppose h is equal to 7. That's just distance. What's the area of the trapezoid? So here's where we go. So it's 1/2. So put that's 1/2 out here. That's always part of your formula. And then in the parentheses it says B1 plus B2. So it says add up the bases. And it looks like this one. Let me make this one 4. I'll make this one 4. and this one's 6. From the visual, you can see that it appears that the bottom base is longer, so let's do it like that. So then this is going to be 4 plus 6. And then the altitude is the length of the line in red, the perpendicular, from this side to this side. This is a perpendicular 90 degrees right there. And that's 7. Again, that could be in feet, inches, we just say units. Equals to 1/2. And then 4 and 6 is 10 times 7. Now, you could multiply the 10 and the 7 and then take half of that. Or you can just say, okay, let's multiply the half and the 10. So 1/2 of 10 is 5. And then that's still times 7. So that's 35. And that's units. Because it's area, it's, say, square units. I'll just call it U. This could be inches, feet, whatever. So the answer to this is 35 square units. Now let's look at the next one. This is a triangle, and the area of a triangle is 1/2 the base. So in this case, this is the base. There's actually 3 bases here. This is another base, this is another base. All you need is 1, and you need the perpendicular from the opposite vertex. So this red line is the altitude perpendicular to the side base here, B. So let's say the base is 4. That could be, again, any units, inches, feet. Say the base is 4. Let's say the height is 10. So the formula for the area says, okay, the area is going to be equal to 1/2 the base, 4, and the height or altitude is 10. So this is equal to, again, I could say, okay, I want to multiply those 3 out. So I'll say 1/2 of 4 is 2, and then 2 times 20, or 2 times 10 is 20. And that's, again, area is always square units. I didn't give the units here, but it could be square inches, square feet, square centimeters. I could say 4 times 10 also here. 4 times 10 is 40, and then half of 40 is 20. So here it is. We'll look at more applications using equations involving these formulas again in the next video. Thanks for watching. We'll see you next time.